Okay, now the last thing I want to say is that when the absolute value of u equals c, and c is negative, so if c is less than 0, then this equation has no solution. And the reason for that is, the absolute value of u is the distance from u to the origin, and so it's impossible to have a negative different distance from a point u to the origin. Okay, so that's just a little reminder. Now, we want to look at some different notations. These are basically the three notations that we'll use in this book. The first is interval notation, and so that's where you have a comma b, and then you have brackets or parentheses to denote what the boundary is. So we use brackets to denote the fact that the endpoint is in the interval. So like if you were looking at the interval from 0 to 1 and you wanted to include 0 and 1 into that, then you would use the bracket and you would write 0 comma 1. If you don't want to include 0 and 1, then you're going to use parentheses. Some people draw this as open circles. But the idea is that you're going to include all the points between 0 and 1, but you're not going to include 0 and 1. You're not going to include the endpoints. So parentheses are for when the endpoints are not in the interval. Brackets are for when they're in the interval. And so this table has every possible interval, and then the graph, and also the set builder notation. So the first is the open interval from a to b. That means that you're not including the point a, you're not including the point b, but you're including every point between a and b. And in set builder notation, you write that as all x, the vertical line means such that a is less than x and x is less than b. So you're taking all the x such that x is greater than a and strictly less than b. Now, if you use the square brackets, then the interval from a to b is the closed interval from a to b, and that means that's all the x such that x is greater than or equal to a, and x is less than or equal to b. So x is allowed to be equal to b or a in this case. And then the graph looks something like this. We use square brackets or a closed dot to denote the fact that you're including the endpoints. And then every other interval is shown here. So I'm not going to spend too much more time on that, but I'd like to just draw a couple graphs and express these intervals in set builder notation. So in example 2, we have the open interval. Well, sorry, it's the set of all x such that x must be strictly bigger than -1, but less than or equal to 4. Okay, so the closed bracket on the right means that x is allowed to equal 4. The open bracket on the left means that x cannot equal -1. It has to be strictly bigger than -1. And on a graph, or on a number line, let's see here. Here's 0, -1, -2, 1, 2, 3, 4, 5. The interval would look like this. It would be an open interval on the left and a closed on the right, and it would be all points in between. So strictly greater than -1 and less than or equal to 4. Okay, now this other interval is equal to the set of all x such that x is less than -2. So it's all the numbers that are strictly bigger than -infinity. Well, every number is bigger than -infinity, so that's not really a restriction. And then x has to be strictly less than -2. So let me draw that. So here's 0, 1, -1, -2, -3, -4, and so on. The interval is going to look like this. All values that are strictly less than -2. And that's all there is to it.